Hi, my name is Bindu Nair and welcome to my tutorial on understanding Node.js. Node.js has been my topic of research and presentation for project 3, class CS6320. In this tutorial, I have aimed this to be a quick primer for understanding Node.js, and the way I've dealt with the details in here is by addressing the three main questions of what, why, and where as it relates to Node.js. So we look at what is it that makes it really a compelling server-side JavaScript framework, what are the key differentiators and for Node.js as it compares with other frameworks, who uses Node.js today, and then we'll finally follow it up with a hello world example on the same thing. And the sidebar menu on this tutorial can be used at any time to jump in between sections and navigate the length of the document. I'll jump straight in. Let's see, what is Node.js. So Node.js is an open source server-side platform that is all JavaScript, that is written in JavaScript, and it is for JavaScript applications, and it is especially a good fit for building scalable and event-driven applications. There are some phrases in here that through the course of tutorial will become more clear as I go through the different sections. So for now in this section, let's just look at some facts around Node.js, what it comprises of, and who created it. So the author is Ryan Dahl, and it was first published for Linux in 2009. So it was the Unix platform, Node.js for Unix platforms, that came first. And most of Node.js is written in JavaScript, and there is also C++. So it's really a combination of JavaScript and C++ that it is implemented in. It's built on top of Google's V8 JavaScript engine. The JavaScript engine, V8 engine, came out in 2008 or something, and Google built it for their Chrome browser, and it was optimized for speed when it came out. So for the creators of Node.js, that was a great foundation to build on. So again, it runs standalone JavaScript applications on both the client and the server. So it's the same code. We are used to JavaScript on the client side. The same kind of code can run on the server now with Node.js. And Ryan Dahl actually built it from scratch, using a non-blocking event-driven model. And this model we'll talk about in detail in the next section, which is why use Node.js, because this is kind of an underlying point about what makes Node.js such a good platform. That was something that Ryan Dahl built from scratch. And the next point, when you install Node.js, it's not like Apache that you install a web server, that it comes with this config directories and views and controllers and all these folder structures and where the web archive goes in and all that. It's not a pre-packaged web server, but it can be, right? It's a server-side framework, so it definitely can be a web server. The reason I make this point is that what you get with Node.js is a JavaScript runtime engine. You give it JavaScript code and it runs it. So if you want a web server, you have to write something, or you have to have some a library on top of it that makes it behave like a web server. But essentially at its core, what Node.js is basically something that can run JavaScript. So that's also, what's different between installing Apache versus getting Node.js. Okay, where it fits in the whole ecosystem of all these different frameworks. It's not the first JavaScript framework to be out there, but what it does really well is do client to server request in real time. It can really scale to millions of concurrent users and be really performant. So when you want to do real-time applications, Node.js might be a very compelling choice for you from various other frameworks that are out there. It uses libuv, which is a cross-platform non-blocking API for I/O. When you use when you talk about JavaScript essentially historically has been running on the browser on the client side. So JavaScript never had to do I/O. So JavaScript never came with anything with which you could do I/O, right? So Ryan Dahl had to have, when he took JavaScript to the server, he had to have a way to do I/O and do socket programming, support for sockets and things like that. So libuv is that cross-platform API that does it for Node.js. So Node.js is basically your engine, which is your runtime engine that can compile JavaScript applications and run it. A set of libraries on top of it, and libuv that gives you the capability to do server-side tasks like I/O and working with sockets. There's a nice robust community out there that is doing Node.js and building all these different libraries, so reuse of code is possible. So things with databases, Facebook logging, payment gateways, etc., which is now becoming mainstay with web applications, is becoming something that are, it's like quick plug and play libraries. When you use something new, you will always find that if you have a very robust online community that you can participate, contribute, and partake in, that becomes a key point, a big factor for your success. So again, simply put, Node.js is JavaScript on the server. It's a runtime that can execute your JavaScript. So that kind of introduces to you what Node.js is and what are the components and what is it that it's in the business of doing. Okay, so if you know what Node.js is, then the next question that you would hopefully ask is, why Node.js? Okay, so there's this thing, but then there is PHP and there's JSP and there is Angular. When you talk of JavaScript, there's Angular, there's Rhino, which is kind of like Node.js. So clearly that's not Node.js is not the only thing that's out there. Why would I use it? Help me fit this in. Help me figure out where does this fit in as far as the user needs go. When would you use it? So why use Node.js? What is it that makes it trump other server-side solutions like PHP? And the simple answer to it, and it's really simple to say it, but it's huge when it comes to web applications, and that is the fact that it is really fast and it can scale really well. And what makes it so awesome? It's because of its event-driven concurrency model. So it's one of the two biggest key differentiators of why Node.js can be so fast and scalable as compared to other server-side frameworks that are out there. And one of the reasons is the event-driven model that it has. So let's look at what is it that we know traditionally, the traditional model of a client server request. So the classic diagram that I have here is where you have JavaScript client and a PHP server. So what happens? The client makes a request to the server. There's PHP code running on the background. It maybe talks to a database or something. It generates the HTML page, gives it back to the client, and JavaScript code is again run on the browser, and the final HTML is rendered to the client. So if you break that down, what's happening there? The process goes like that. The client asks for something. What the server does, it spawns a dedicated thread for every child request. It's either a child process or a thread. If it's a multi-threaded program, then it spawns a thread. If it is not multi-threaded but just multitasking, then it's a child process. But there's a dedicated process or a thread for every child request. There's a main server thread that continues to accept client requests. So as more and more clients come in, there are a lot of threads waiting for the CPU slice and competing for memory. And one of the slowest things to do in such client requests is to do I/O calls. I/O or database lookups just tend to be the slowest and long-running tasks. So what happens when a thread is about to do a blocking I/O call is that it's at a risk of being preempted because the time slice is up. So you have threads that have to do these blocking, time-consuming calls and could be preempted. And so that leads to a catch-22 situation where you have many waiting threads. They hold up resources, and at the end of it, at some point, the number of max threads is reached, and so you're actually pitting it against the limits, the resources in the system, and it will stall from being able to scale linearly. And as new client requests come in, and as you try to scale more and more, you will see that you do not see that the system does not scale linearly in terms of performance. So that's your traditional system. So on the server side, if you were to write code, what does that look like? You write PHP code. This is not exactly PHP, this is pseudocode, but you have something that goes and reads from the database. That becomes a thread which is sitting there in a synchronized block. This is a synchronized blocking call. Nothing's going to happen until this call gets out. And so print data and do something more. This whole thread is blocking on this call and will not get to print data and do something more unless that is done. Now enter JavaScript and hence Node.js. What we solved this problem of potentially having lots of blocking calls and not being able to scale by having an event-driven model. And it is really, Node.js just takes the credit of this event-driven model. It's not Node.js that brings it to the table. It's JavaScript that supports it. JavaScript always had this event-driven model. It is because Node.js uses JavaScript, it becomes a huge advantage for Node.js. In event-driven model, there's only a single thread from the application layer. There's only a single process that is running. And because it's a single, there are no multiple threads that is spawned. And because of it, there's no contention for CPU. The CPU has only to handle a single process at that application layer. So whatever memory and whatever CPU is available, it's all available to this one process. So how does this compare in terms of the other traditional models? So in this event-driven model, the client asks for something. The server, the Node server, which is also running JavaScript at this point, gets the client request and says, "Oh, I need to go do something. Do a database lookup. Do an I/O call. Write to a WebSocket." Okay, it delegates it. It creates an event, and it delegates that to an OS level thread. It simply says, "Here, this is the job to be done, and at the end of this job, here is a function that you call. So you do the job and you call me, and you let me know by sending this event. That's the kind of handshake that happens. So it creates a callback function, it creates an event, it attaches that event to the callback function, and it hands it off to the kind of the OS level C++ threads to handle it. It's not the application server doing this, but it's a layer below that deals with it. And so now the server level process is just, it hands it off and says, okay, I am ready to do another client request. There's another component to it called the event loop. This is a gigantic loop process that just runs there and looks at a queue. This is the queue where the events come in. Once the data becomes available, then the events are fired, and the events comes into the event queue. And it's this process that looks at an event and says, oh, this event is available. Let me look at the function, the event handler attached with this event, and the event handler is fired, and that means the data is sent back to the client. So in all of this, from the application layer, there's only a single thread of process running at all times. So there's no contention, and because of this, there's really no blocking calls happening. All the processes are kind of delegating, talking to each other, and just continuously running. There's no blocking calls. And so this model really scales well. So as you add more clients to it is when you really see the power that comes out of this solution, is when you add more and more clients to this thing. There is and if you can add more resources, which is considered cheap these days, the system does scale pretty well in a linear fashion. And on the server side now, the code looks like this. The process comes in and it says, okay, here I'm registering a function, and here's the data that I'm interested in. When this data is available, here's the event to call. Here's the callback function to call. It registers this function, creates the event, registers this function, and that's it. It's done, and then it's free to do something more. So it's as quick as that. It just runs some lines of code and comes through. So scaling becomes a piece of cake. The second of the two really important things, key differentiator for Node.js, is the asynchronous nature of it. Again, it's really tied to the first point. It's the libuv cross-platform library that abstracts the asynchronous calls, the system calls that Node.js does. And all those APIs are already written in an asynchronous, non-blocking way. And that's the good thing about Node.js. As a first-time beginner, you come in and you start calling all these APIs to do the work. The thing that you need to know is that those API calls are written in a non-blocking, event-driven manner, and that's why as you write your programs, you are writing this really highly scalable applications. Compare that to C or C++ or C, where you have these system calls like read and fprintf, which do server-side things. These are implemented in a blocking manner. So there's no way, if you use those environments, to get around it, because all these supporting APIs are blocking calls. So you write your program, you use the APIs, and you have to deal with those consequences. The great thing about the asynchronous non-blocking I/O is that the Node.js is written on these platforms already available that implements it in an asynchronous non-blocking manner. And it's all asynchronous, so it's not only non-blocking, it's all in the background process. So really, from a client perspective, you just do not see any lag in terms of when the request is made and when you see the response. So that's what makes Node.js so Awesome. And lastly, but not the least, point is about JavaScript programming itself. And this is something developers really start to like, you know. As a web application developer, you tend to know some JavaScript, and then imagine that you just have to do only the same JavaScript. You don't have to deal with multiple syntaxes like JavaScript on the client, PHP or Ruby on the back end, different data formats to sync up, none of that. If you know JavaScript, you come in here, you write JavaScript on the client, the same code on the server with usage of some extra APIs, which are all non-blocking asynchronous. So it gets you started in a good way. And because of this, there is a really good adoption among the web application community out there. So people are writing a lot of code and APIs, and all this is reusable. So there's a lot of libraries already available for doing all these, you know, great things that most web applications need, like for file server access and user authentication, session management, and all that. So because you have that ever-growing repository, you don't have to kind of reinvent the wheel each time. So that's a great thing. You know, again, a success for using new environments like this is based largely upon the kind of support you get, online support you get. And for Node.js, that is very strong, and it's growing as we speak. So that covers, you know, why one would use Node.js and where it fits in. The second, the last question here to tackle is, you know, who uses Node.js? So it's okay, so it's awesome, but right now, how is it doing? Who's using it? And it turns out that it has some really hefty names under its belt. You know, a lot of big companies use it to do some critical functions in their whole stack, technology stack, both internally and also in terms of hosting Node.js services or APIs. A whole list is available in this link right here. So you can look at this. It's a really long, exhaustive list of different companies. I just make a reference to some of the bigger companies of what they do. Walmart uses it. Microsoft is the one that contributes to Node.js on Windows. That's what I'm using. When Randall wrote it, it was meant for Linux, Unix systems. It also uses internally. Yahoo.com is based heavily on Node.js, and they have also built a Mojito framework, which is another client-side, server-side application framework that's built on top of Node.js. Yammer uses it. Yammer is, again, this chat community kind of application. So it's got lots of users, and it's real-time chat applications, so it uses that. LinkedIn, GE, eBay, Dow Jones are some big names that uses it. So there's really strong adoption and a good case for you know, real-time scalable applications, because all these capabilities, you know, kind of support that use case. And finally, let's look at how to create Hello World with Node.js. In terms of, so step one is, of course, install. This I found to be really easy. This is like a one-step install. So you go to nodejs.org. That's your one-stop shop for understanding Node.js, and there's a lot of stuff in here. But this is one green button here, and you get Node.js, no other configuration required out of the box, and that's a really quick install. Then the next thing, so when you install it, you get two things. There's the core components of Node.js, and you get a Node package manager. And Node package manager is very much like the Ruby gem that we looked at. So it's something that lets you manage your dependencies, install, manage, configure your dependencies. So in this tutorial, I'm using Express. Express is Node's web application framework, and what it means is that, like I said, when you install Node.js, you don't have a web server up and running by default. So you need something to make Node.js behave like a web server. And there are at least a couple of ways that I know that you can do it. One is to simply write JavaScript to create an HTTP instance of an HTTP server. Node.js will run that JavaScript code and have that in HTTP server up and running. That's one way. Second way is to use Express, which is an already ready-made web application framework that comes with Node. If you install it, that is. So I decided to use it because it demonstrates the use of npm, of how to use npm to install dependencies. So I said, okay, npm, which was installed in step 1, go get Express for me. And just those 2 lines of code gets me Express, and I didn't have to know anything about it. It prints something to my console, and that's all good. So once you're here, because I want to create a web server application and I'm using Express, I'll create an Express project. So step 3 is very similar to creating a web application project using Eclipse. When, say, you're using GAE, you start with Eclipse and create a web application project. And what do you do with that? What you get is an application project structure, a structure that lets you manage your views and your controllers and models and your resources and all that. So in a similar manner, Express lets you do that. So you create, you say Express, a name of your project, and you get a bare bones structure here. As you can see, there's a view folder, there's folders to put your JavaScript, your images, your style sheets and all that. And the next thing that you do, so okay, you have your bare bones application. Now your application needs to do something. Typically your application would need to write to a database. So you have to say, oh, my application depends on this database. So say you were going to use MongoDB. So the first thing that you do is to register your dependencies. You to define your dependencies for the application so that it can go and install those things. And the way you do that is to open this file called package.json. It's just a dependency file, plain text, and it's created every time you create an application. And you open that file and it looks like this. It just plain text defines your project, version, all that, and a set of dependencies. This much was already served up to you. Express was part of it. Jade is the content handler, the HTML preprocessor that comes with Node. So say I wanted MongoDB or Monk, which is another framework. So MongoDB, so all I do is I say I need MongoDB for this, it's my dependency, and you write those 2 lines in there, and you can just install there, and it'll bring in all the libraries of MongoDB. You do not have to do a separate installation of MongoDB, figure that one out. Typically that's what you usually have to do, right? We had to do something like that with Ruby, where you had the Ruby project set up, then you had to do figure out the backend migration. There's default stuff that comes with it, but I remember struggling with SQLite, which I had to install separately. It did not come with it, or somehow my installation did not work. But there's a lot of parallels between Ruby and Node.js. These frameworks kind of have a lot of things in common. So in a similar way, we say I want MongoDB, and it will bring that in. So how do you do that? You just you run the npm install command, and once you've finished putting all your dependencies in this file and you run npm install, you're done. That's it. Your application is ready to go if that's all you need. And so at this point you have a full functioning application that is just waiting to run. It's a simple thing. We're not doing much with it at this time, but it's there. So how do you run your application? All you do is go to your application project directory and say npm start. And when you do that, and a default web server starts up, and that's because you have Express making this possible, and the default port is 3000. And so when you go there, you get an default Express's welcome page saying that. Okay, so we got to this point. We have like a web server running because of Express, but we want to do hello world. So we are one step short of hello world, and to do this, let's see what's involved here. So to do this, in Node project 1 folder, you also something called app.js. And app.js is everything that your application is going to do. It's the stuff that has most of your defines the big module objects that the application is going to use. Excuse me. So if you open it in the editor, you'll see a bunch of JavaScript variable declarations like that. It's basically handles, basically variables that are handles to many things in your applications, like the routes that it's going to use, your cookie parser, dependencies like your Express and things like that. So Express sets that up, because you got Express, it sets what it needs inside app.js, right? It sets up the routes, which you're familiar from Ruby again. And then also there's a line called var app equal to Express. Here we have a handle, we have a object to our application itself, and that's something that Express just puts in there. You don't have to code it. I mean, that's a simple line of code, and that whole object is available for you to share with any other module, and that becomes another powerful thing, which is available ready to go, because when you have different applications talking to each other between modules, you have these objects that can be just exported like it's in a variable, and these properties, different properties of the applications can be shared. And so what are the properties of the applications? You get to know where to find its view, what are the template engine, what are the different routes that you use, and what are the images and resources attached to that application. So just that app variable has all that information, right? So if you look at app.js, this is some excerpts I did use. App is the variable that Express makes available to us, and app.js actually sets all these things. It sets the view path, it sets the logger, it sets the routes for that path, right? The URL routing and all that. So that's really attacking the core concept of Node, is that all its modules export an object that can be used globally in different parts of the code. So module.export equal to app. So it becomes this globally shared object that you can use. So now, as you see, we've already defined a default route for the app, right? It's the default. If you give it the URL ending with the application name, there is already a default routing rule that is defined for it. And where does it go? Where does it point it to? There is code in there in app.js where you have the router, which is again handled to the router, and it is mapped to index.html, right? So it says render index for this router and for this get of this URL service index.html. So we note that we already have the router variable here, right? Which is an object which can contain many routing rules, really. And this is already given to us, a default one. A router is created, a routing rule is created and attached to that router, which points to index.html. So if we wanted to have our own page that says hello world.html, the way you use Express and Node's default HTML preprocessor is to simply extend that and write your own hello world page, hello world router method. So you give it the URL and then you point to the name of the HTML resource that you want to use, and you can even pass it, and this is the beauty of the thing, you can even pass it a title right here, right? So we basically use the same technique that Express and Jade uses by default. So all we did was use the built-in router object and assign it define a new routing rule to it using our hello world application name as something to distinguish with the new page that we are creating. And that's it. And we almost there. We are using Jade, which is again the preprocessor, HTML preprocessor. So that's like a template. Jade gives you a template to create your HTML content. So we just created a routing rule for something called Hello World. We gave it the name here, but where is hello world.html? We haven't yet created that. That's your last step. So we have to create it, and that's where Jade comes in. So you go into your project views folder, and there's something called index.jade, and that's like a template file that's there for you, right? So use that template file, copy and rename it to hello world.jade. And its contents looks like this. Okay, it extends a layout, which is already, HTML layout, and then defines a block and a h1 title, and so it has some basic content. Look how it uses the title here, and that title comes from here, from the app.js, and we have already defined it as hello world there. So pretty much just by renaming index.jade, that template is already there. You already have the workings to output a simple hello world string. You didn't have to hard code it anywhere. You just created your routing rule, and there you have it. By just creating your routing rule with the new name of your HTML, and then you create your hello world.jade, which is your HTML directive for Jade preprocessor, and that's it. The Jade, when it sees it, will create the underlying hello world HTML when you're ready to look at it. So finally, you rerun your server, start the server again by doing npm start, like we did before. You go to localhost, and now hello world, that's your new URL, and you will see hello world like you would be expecting. So that is a short hello world demonstration of that demonstrates installation of Node.js, and how to use some of those the default Express application framework and the Jade preprocessor to start up a small web server and have the HTML content rendered on the client. And finally, in terms of putting these tutorials together, I've used a couple of images from different sites, and of course lots of reading from these websites. So there's a section that details all the different references that I've used. The best reference that I found is obviously Node.js.org. That is pretty exhaustive, and I also felt that trying to do a tutorial from here, the simplest one is fine, but after that you kind of have to read between the lines, and things can get really messy really quickly, because it's again contributed by the people who know Node.js really well. So sometimes it's easier for I found it easier to kind of read through other references which were much simpler. And in some cases, of course, stackoverflow.com was always helpful for very specific for answering and getting a handle of very specific questions that I had in the process. I guess rest of what I have in here is pretty self-explanatory. And with that, I conclude the tutorial. I hope you found this useful, and thank you for listening.